Hi everyone, welcome back to my channel Hag Random Information. Answer for every valid question. In the previous video lectures, we just saw type 1 numericals of module 1. Let us go through type 2 numericals in this video. Let's get into the video. In the previous video lectures, we saw type 1 numericals on module 1 power system analysis subject. In this video, let us solve type 2 problems. For the detailed explanation how to solve, just see the example 1 of type 1 problems. I have detailedly explained how to take the formulas and how to take it. In the type 2 I will go faster in the calculation part. Without any delay, go to the type 2 problems. The question was given over here. The diagram of a radial transmission line system is shown below. The ratings and the reactance of various components are shown. A load of 60 megawatt at 0.9 power factor load, this is a load, static load, is tapped from the 66 kilovolt bus bar. 66 kilovolt bus bar, which is to be maintained at 60 kilovolt. Calculate the generator terminal voltage V1. This is bus bar, right? Vertical line. We have to calculate bus bar voltage. This is the type 2 problems I mentioned. The bus bar voltages we have to calculate. We need to calculate V1 and also draw a PU diagrams. Next, in this question they did not mention base values. Base values. So therefore, first sectionalize this simple power system into three components. This is section 1 and this is section 2. This is section 3. Choose any of the section as the base values. For the base values, I'll choose generator. Suppose if I choose generator, the generator voltage or power, they did not mention anything in the question, so neglect it. In this load, if you choose this section as base values, they gave power but they did not mention any voltage values, though leave it. Next, left out with the transmission line section, they mentioned transmission line section. Take base power as 100 MV 100. This is same, so I choose base power as T1 T2 transformers as 100 MVA and base voltage common in these two. This is 11 bar 220, 220 bar 66, 220, 220 is common. I will take 220 as base voltage. For transmission line section, we choose. Next step is new base voltages of all remaining sections. New base voltage for transmission line section. Initially you write which they gave or you took base powers. New base voltage for transmission line section, we choose on that 220 kilovolt. This is 220 kilovolt. Say new base voltage for generator section. This section, previous voltage section, we are calculating this, right? Previous section voltage is 220 kilovolt. 220 previous section voltage. This is primary, this is secondary, right? We are calculating generator section voltage. We are moving from transmission line to generator section, so this implies secondary to primary of T1. Secondary to primary means multiplied by 1 by k. 1 by k means V1 by V2. V1 by V2 of T1 transformer. T1 transformer, this is V1 V2. 220. V1 is 11 divided by 220. 220 given as 11 kV. And left with load section, new base voltage for load section. This is equal to this section. Just previous we have calculated 11 kV, but now we are calculating load section voltage, new base voltage. So we need to refer this. Previous section voltage is 220 multiplied by since these loads are connected secondary side of T2, this becomes primary. We are calculating this section voltage, so therefore we are moving from transmission line section to the load section. Thus implies primary to secondary. Primary to secondary multiplied by K. K implies V2 by V1. V2 by V1 of T2 transformer. V2 by V1 66 by 220. 66 by 220. 220 get cancelled. We left out 66 kilowatt. And now we need to in the third step we need to calculate new reactances, new PU reactances. First we calculate for generator. For see here, for generator we no need to calculate because they did not mention any voltages or powers, so we can't calculate the reactance of generator, just neglect it. Then now we need to calculate for T1. xt1 pu new is equal to old is given as 10%, that is 0.1 multiplied by power. New base power is 100 MVA divided by old base power also 100 MVA given, multiplied by voltage section. Old voltage means they have give. I took this is as primary. I will take 11. This section voltage now. Generator section voltage is 11 whole square. This get cancelled. All are same. 0.1 JPU. Next, X. We have calculated T1 reactance. Now let us calculate transmission line section, that is given as transmission line PU new is equal to, they gave 150J, 150J multiplied by new base power is 100 and new base voltage of transmission line section, this 220 whole square. Take into the complex mode, calcium complex mode, 150, use brackets while using complex mode, 100 divided by 220 whole square. We got as 0.31 approximately JPU. And now we completed with the transmission line, and let us go to the T2. xt2 pu new is equal to old pu is 8%, 0.08 multiplied by power. Power is new base power is 100 and T2 old power also 100. See, 100 power multiplied by old voltage. Here, old voltage I will take primary side 220 divided by primary side. I took primary side section voltage is 220 whole the square. Whole thing get cancels. We left out with 0.08 JPU. Now we need to draw PU reactance diagram. PU reactance diagram. Generator. So connect XG series with EG. And then T1 transformer XT1 and transmission line XTL and transformer to XT2 and we need to just mention load. No need to calculate the load reactance pu new pu, because they did not mention any voltage, they gave power only. And consider this as v1, consider this as v2. Since we need to from this figure, this is v1, right? Here v1, generator after bus bar connection, so therefore v1. For this voltage v2, this is v2, or we can say this is as v2. This equivalent, for understanding I will draw a equivalent of this. This is, assume that this is v1 pu, and total impedance, I will add this total impedances. That is, from calculation we got to know that 0.1 j for this, and 0.31 j, 0.08 j. After adding these all, we get 0.49 j pu after totaling these all. And we connect a load impedance, take it as voltage source, that is v2 pu, plus minus plus minus, and just take one current flow ipu. For the calculation of v1, for the calculation of v1 voltage, therefore we need to take xd total, that is this. To calculate this voltage, they gave generator voltage terminal v1, we have to calculate v1. To calculate v1 voltage, we need to add this reactances multiplied by this voltage, sorry, this current. xd total, these all total 0.1 plus 0.31 plus 0.08 whole the j, this constitutes pu. Now we need a v2, v2 pu is equal to load voltages they gave here in the question. V2 pu means v actual divided by v base. V actual they gave here, v actually 60 kilovolt, v actually 60 kilovolt, and v base, we need v base. V base means this section voltage. What is this section voltage? We have calculated as 66 kilovolt. We have to write here 66. If we divide, we get 0.909 pu. We have calculated xd total, that is this is xd total, and we have calculated v2 pu. Therefore, applying KVL to this circuit, v1 pu, that is this is the generator voltage we need to calculate, is equal to v2 pu plus xd total into ipu. Let it be equation 1. Now we got a v2 pu and xd total, which we need to calculate ipu. Since ipu is equal to I actual, right? I actual by I base. Let it be equation 2. Let us find out I actual. That is, since we know that P is equal to VL IL cos phi multiplied by root 3 VL IL cos phi. From this implies IL is equal to P divided by VL root 3 cos phi. So I actual is equal to, according to this formula, what is power? Power at load section only. Remember, since IPU we are calculating load section, we need to take. So power is 60 MV, 60, just write 60. Then voltage of this section, that is 60 volts. 60 into root 3, this is root 3 into cos phi. Power factor is given 0.9, so 0.9. Power factor means cos phi, this whole becomes cos phi is equal to 0.9 multiplied by, and since 60 volt, this is kV, this is 60 kV, and this is MV. To we need to convert from theory. We know that to numerator and denominator should be equal unit. So in mw, to convert into kW, we multiply by 10 raised to 3. So after calculating this, just skip these units. 60 get cancels. After calculating whole the thing, that is 100 divided by 0.9 root 3, we got 641.5 amperes. Now we need IB. IB, it's a standard formula, just note it down. MVA base into 10 raised to 3 divided by root 3 multiplied by KVB base. This is a standard formula. This is the new base. New base power is 100 MVA. 100 MVA into 10 raised to 3 divided by root 3 into new base kilovolt is 220. After calculating this all, we get 874.77 amperes. Therefore equation 2 implies, this is equation 2 implies IPU is equal to 641.5 divided by 874.77. This total we got as 0.733. Here while calculating this power, while calculating this power, we just mention this angle to take the angle. This is cos inverse of phi. We need to take this angle. Here only I forgot to add this cos inverse of 0.9, and we need to take minus here because it's lag means minus, lead means plus. Cos inverse of given power factor 0.9 multiplied by minus, here becomes minus 25.84. in this here 25.84 angle. We got IPU also. Therefore equation 1, where it is equation 1, V1 PU is equal to V2 PU 0.909 plus XD, that is 0.49 J multiplied by this 0. Use the brackets for complex numbers. It becomes simple for putting into the calci. All these things will becomes 1.1135 16.87 degree PU. This is V1 PU. We got final answer in the PU, but we have to keep this in actual values. To convert this actual value, since we know that VPU, whatever it may be, VPU is equal to V actual divided by V base, right? We need now V actual. Therefore V actual, that is V1 actual is equal to VPU multiplied by V base. VPU we just calculated, VPU multiplied by, we no need to multiply this angle, V base voltage of generator terminal, because we need V1 is related to the generator terminal. Base voltage is 11 kilovolt, multiply by 11 is equal to 12.12 kilovolt. V1 actual. This is a generator terminal bus bar voltage. This type 1 type 2 problem, till this we have completed module 1 of power system analysis subject. Let us go through the module 2 in the next videos, but in the next video I want to make the video on how the question papers framed from the module 1, and if sometimes the question paper may be difficult, in that case how to pass, how to score in the module 1. I will explain how to score from the module 1, and I will refer some question papers in the next video. Afterwards we will go to the module 2. If you really like this video, please share and subscribe my channel and comment me for any queries and suggestions in the comment section. Thank you for watching. Bye bye. Take care.